Yeah, today I wanted to talk about kind of something that's often forgotten in the kind of art of operationalizing machine learning, and that's kind of speeding up, making safe, and making regular the art of model deployment. This is related to some work that um, we did recently over the past year on my team at Stripe, and so I just wanted to kind of quickly run through why deploying models often is valuable and kind of the skills needed to do so and a few tips that we learned along the way. All right. So we'll break it down into these three parts. One, I think there's a few things that are obvious about why you would want to redeploy models regularly and some that are less obvious. So we'll talk about those. Two, I think it's kind of interesting because like the field of ML, as probably most of you know at this conference, is just like keeps eating other fields. So like, it used to be like just statistics and then just modeling and then data engineering and then like ops. And so I'll talk about that a little bit. And then, yeah, last but not least, kind of just a few lessons learned from our journey of improving our process of releasing models. It's definitely not the answers to the question of how do you make model releases amazing, but there's a few pointers. All right. So what's the value of regularly deploying ML models? I think, traditionally, I would say, at least as like a data scientist, you often think about like, okay, I'm going to build this model and then eventually I'm going to ship it. And those tasks are sort of like the large tasks, both the modeling, but then also all the engineering required to ship it. And often what gets left by the wayside is, okay, but what happens when we need to update the model? What happens when we have new features? What happens when we notice some drift? Like, how do we correct it? And so there's basically like 3/4 big reasons I would say you need to regularly redeploy your ML models. The most obvious one is drift. So for many use cases where you could continuously learn from the world, where you're learning something that changes, an example is what my team does at Stripe, which is fraud prevention, where people that commit fraud are always looking for new ways to commit fraud. Then any model that you train today will be obsolete tomorrow. The question is only like by how much will it be obsolete? And so here's an example kind of like on the right of a toy example, of course, like, if you don't retrain, you're just slowly degrade in performance once you release your models. But if you retrain regularly, you can kind of recapture that level of performance. We talk a little bit about it on our blog, which I'll link at the end. But for us, we've realized that like for fraud prevention, for example, 1 month of staleness translates to roughly 0.5% performance drop. So every month that we don't release a model, we just lose 0.5% of performance. And conversely, if you just re-release a model a month later, you just got a 0.5% performance gain with kind of no effort. So that's one reason. The other one is sort of similar but more subtle. Even if it's not a slow drift of the world shifting under your feet, companies change, your users change. And so regularly you'll see that they change in subtle ways. Maybe if you launch in a whole new country, you'll think, oh, well, I guess I should retrain like our fraud models or our customer prediction models or, any other models. But, if like one of your users slowly has started like onboarding more people or like they expanded to a different geo or some subtle things can happen, which can cause your models to, slowly become out of date and eventually just become basically train on a completely different distribution from what your inference is today. So here I have countries as an example. And finally, I think the last reason is kind of like the bottleneck. We'd realized that we'd optimized our experimentation enough that we could like make a simple change to like our data feature or our like data filtering, see that, oh, that's great, this change that gives us like a 2% boost in performance, let's say, but then shipping it was weeks and weeks of work. And so in the end, like even though we had optimized like one of the iteration loops that you care about as an ML team, the other one was so much bigger that's why we chose to focus on that one. So if you can experiment quickly, it's great, but then you have to be able to ship quickly. And the sub part to that is if the model you're working on is important, you should be able to fix it really quickly if it breaks. And so deploying models should be something that you're able to do kind of like quickly and safely. So what skill sets do you need to, regularly deploy models? We already said that, like to be like I guess a 10x ML engineer, you need to like know stats and like modeling and be a really good software engineer and be a good data engineer. So what else are we adding onto the pile? This is my mental model of it. Starting from the left, like to get a good model, you kind of need 90% data generation and cleaning and 10% modeling. And then once you have a good model, moving on to the middle, if you want to ship this model, 10% of the work was getting the good model. 90% that remains is now, relying on software engineering best practices. But once you've shipped the model, if you want to be able to like reliably serve it and kind of update it, then all of that work that we're kind of going to talk about is mostly on the operational side. This is basically kind of like getting to a level where you excel at running your like training and evaluation pipelines and your deployment pipelines. So it's very operational work, but it has huge value. So, as I said, this is kind of like a fuzzy problem, a problem that's clearly worth solving, but one where there's, I don't think, kind of like clear best practices. So I'll share 3 or 4 tips depending on how you count that helped us along the route of sort of like tripling the speed at which we release models and kind of capturing those gains I had mentioned where our models are now always fresh. So one is usually when people think about model training, they think about this box at the top right. They think, okay, well, I train my model. But really, if you think about the process of producing a model, it is a much more complicated and in fact like almost a cyclical process where first you kind of generate data, you filter it, you generate your features, you generate your training sets and your evaluation sets, you train your model, you evaluate it on said sets, you evaluate it usually for more than just kind of like is loss going down, you evaluate it for like business metrics. So you might have like particular data sets that you want to measure performance on, then you deploy it, then you monitor it. And then usually you measure your model's performance in production, and very often that will feed into the data that you use to train your models, right? Maybe you'll notice that some examples are particularly hard or particularly easy for your current model, and you don't want to select them. So when we say reliably train models, really you should be able to reliably do all of this and do it regularly. And so our solution for this is to basically automate almost all of it. And so basically what you kind of want here is like, can you have every single one of these tasks be a job that can be automated and that you can kind of like kick off so that like all of this runs without a single human in the loop? In our particular use case, we actually keep a human in the loop at kind of 2 spots, which is like for deployment as a way to sanity check, like, yes, this look good, let's deploy this new model, and then to like sanity check that we are indeed happy with production performance later on to make sure that we're not missing out on something. But essentially, the first step in kind of being able to retrain and redeploy models is for that whole process, to not have like, let's say like a data scientist that like does the feature generation themselves and goes in a notebook and like codes a thing like a one-off job, but to have all of this be automated. There's one more trick that we use to de-risk this automated pipeline, because once it's automated, you might be concerned about what could go wrong, and that's leveraging shadow mode. So shadow mode, there's a few blog posts that talk about it, but essentially like the idea of shadow mode is that we also basically deploy not only just our production model to our production environment, but we deploy models that we're thinking about deploying in something called shadow. And so these models make predictions just like the production model, but we just store these predictions for later. And that allows us to really test models like at the end of that pipeline, going back here before we deploy it. We deploy this model to shadow for a little bit, and then we observe how it behaves in production and verify that we're happy with it. So in summary, once you have this whole pipeline, once you have shadow scores, then you just automate it, or then you just schedule it. And so that's basically kind of like putting it all together. The thing that's, I think, the most useful insight here is you can basically have this pipeline that creates models starting from data generation and does it automatically for you, let's say every week. And so let's say like week 1, the first week it'll run. Then the second week, maybe you'll realize a bug. Maybe some other team changes some code, and like all of a sudden you can't produce models anymore. And you'll immediately know, to fix your pipeline so you can guarantee that you can continuously produce models, and that at any point you're ready to redeploy your models, to fix your models if they break, or to just kind of ship your newest changes to production. That's most of it. As I said, there's a technical guide with a lot more information. You can Google these 4 words, you'll find it, or we can paste the link as well. But yeah, that's it. Thanks, everyone.